Today I'm going to be talking about the electromagnetic induction principle induction tester. There is a lot of controversy on the YouTube and social media and so on, not to mention the brains and things like that. They sort of advertise it like a miracle sort of instrument that fell out of the sky type of thing all of a sudden. As it says, the electromagnetic induction principle, induction tester. One thing they show you, you just go over the inductor and, it sort of tells you whether it's good or bad. But they forget to tell you that that particular unit has to be powered. And then, only then, if the inductor is operating, it will produce electromagnetic field, and then with this unit that we started actually making it, and I made it a bit more sensitive than what it is available, with the special probe, it will basically operate exactly the same primary and secondary transformer. Like if you look at it, okay, let me just put this sample. I'm going to use this one here. Basically, you stick the battery, okay, wait, let me start from scratch. Double-sided tape, you peel it off, you fit the battery over here, and then, like I've done over there, and there you go. A beautiful, flexible little instrument with the specialized, as I said, probe. Now, how do you basically use it? I'm going to do the quick demo. I've got one here, a switch mode power supply, which uses which is actually a step down. In other words, you feed particular voltage to the input and you get the output. You can lower it with a trim pot. It uses a toroid core. Toroid core inductor, it's very difficult to measure because, as I said, it contains 90% of the magnetic field within the core. So there's no really leakage, but nonetheless, we'll be able to measure it and to pick it up. I'll show you now under the load. And then, of course, I'm going to demo a small little sort of a step up from 0.9 to 5 volt little module. And you can see I'm feeding about 3 volt and I'm getting 5.01, sort of 5.1 volt. So now, and this one here doesn't use a toroid, it uses a potco sort of inductor with the ferrite. So, of course, the instrument, when we do the actual repairs, if you want 100% accuracy, I use the portable spectrum analyzer with a special probe, and then I just bring the probe on top, and then I can immediately pick up with the magnetic probe whether that inductor or component or chip or whatever is operational or not. Is there anything, sort of any signal coming and at what frequency? But nonetheless, you don't want to sort of switch on expensive equipment, and not many people do have it anyway to be able to do the actual measurement. So I just made my own version of the electromagnetic induction principle tester. In other words, okay, I'll start say over here, okay, with the pot core. Now, this is switch mode power supply. It operates at specific frequency, so this inductor keeps on switching on and off, on and off, on and off. It's called a buck converter, but nonetheless. Now, if I bring the probe close by the inductor, you will see the LED lights up. That means there is a magnetic field created by the coil, and that coil is 100%, and most likely, because it's just a single output, the power supply is okay. So if I bring it, can you see over here when I bring it? Okay, I bring it close. Okay, I put it over here or somewhere else. It does not measure. It does not pick up. Okay, but when I bring it on top of the coil, as I said, you have to, be very precise where you're going to sort of position it. Okay, you trial and error till the LED lights up. If it doesn't light up, watch now what's going to happen when I switch off the power supply. Okay, I'm going to switch off the power supply. I'm going to switch off the power supply. Okay, there is no way that you can measure that inductor with any probe whether it's okay or not while it's on the PC board. But nonetheless, so these type of instruments that you see on YouTube, factory made, and even this one, yeah, DIY made, but actually but more sensitive than the factory ones. Let me just switch on again the power. They have got its place, in sort of in the toolbox. And yes, we do use them ourselves, when you trace different faults. Also, not only from the inductor, even this is a switch mode chip. Now, that switch mode chip is got a track over here going to the inductor, and that track also creates electromagnetic induction, electromagnetic field, which can be picked up by a very sensitive pickup coil, pickup element, or whatever you want to call it. Okay, so even if I put it like this, you can see I'm actually picking up on the track. So it's quite sensitive. Okay, now let me put I'm going to put the load now. I'm going to put the say 10 on the output. Okay, and I'm drawing 470 milliampere out of, and I'm feeding about 3 volt or so. Now look at it over there. Okay, now the magnetic field becomes a bit stronger, so I can actually pick it up even a little bit further than just touching the actual coil. So you have to play around till you develop your own techniques whether that particular if it's a multiple power supplies and different coils you want to measure. Some of them are fully driven, some of them are just idling and so on. So you just have to get your positioning proper and play around the coil, because you don't know whether it's on or off or whatever. And if it does not light up whatsoever in any position around the coil, that means that coil is definitely gone. It's no question about it. Okay, now I'm going to go now to the step down switch mode power supply. Now step down, okay, let me just switch off the load. Okay, now step down, this particular module uses a toroid. And toroid, as I said, now there's not much leakage flux. So there's no load. Okay, here is the resistor, which I'm going to connect it up just now, on the load. But if I bring close, you can see there's nothing happening, okay, because the whole magnetic field, there's no load. And if there's no load, the magnetic field is very, very weak. But watch now, once I load the actual power supply, output of the power supply. Okay, so I'm just going to join it over here. Now, magnetic field increases substantially, and when I bring the actual coil, you can see it straight away. Okay, now it's operational. Okay, so I can put it, let me just do it this way. Sorry. You see, it's got the beginning and the end of the coil. As I said, the toroids are very difficult to measure, but nonetheless, you have to develop your own techniques again, because now it's picking up because I have loaded the output of the actual module. Now, if I put it over here, there's nothing happening. There's no measuring on the wires. No electrostatic or, because the electric field, because of the capacitor, it's been faulted to a particular point, so there's not enough strong magnetic field that I can pick up on the wires. Nonetheless, from the chip has got on this side, okay, let me just do this, on this side are the actual legs of the chip. So from under the heatsink goes to the actual coil. So even on that track, which I'm going to just position the probe, you will see it will actually light up the actual light. Let me just find that. Can you see? Okay. Now it's picking up a track. In other words, from here to one of the pins on the chip. Pin number, I can't remember what pin it is, but nonetheless. Okay. Now, watch when I disconnect. Okay. As I said, there is not much electromagnetic field created. There is, because when you measure with a multimeter, but multimeter, you will measure regulated voltage, but there is no load. So there is no virtual current actually flowing through the wires. In order to generate a magnetic field, you need a current to go through. And more so on the toroids, because, as I said, 90% of the magnetic field stays within the actual core because it's encircled. So it doesn't dissipate all over top of thing. So, as I said, one has to develop his own skills, how to apply and how to use. And as I said, one thing that I have got against on the internet, they show you touch the coils and whatever, and you under the impression, that it actually picks up unpowered board. You can measure any coil. No, you can't. The board has to be powered. And then you start sort of tracing, okay, now I just disconnected the load, so it won't, as I said, there's no magnetic field really leakage. Okay. That magnetic field, it induces over here the actual voltage, which now gets amplified and then switches on the LED. Let's go back to this one here again. Okay, you see this one, although it's not connected, because it's a pod core and it's got a lot of, and of course it's just about 0 amp that it's actually drawing, because there's no load on the output. The pod core still gets magnetized and still creates and because it's not shielded, the probe actually picks it up. So just you have to touch and you have to position it properly. But watch now when I actually, again one more time, now I don't have to even touch. From a distance I can actually measure the magnetic sort of field, which gets coupled to the sensor, which produces the voltage and lights up the LED. So that's a basic principle of the instrument. And of course, I made it slightly, I could bias the actual circuitry, that it's a bit more sort of sensitive. So the guys, they have got a bit more sort of versatility. And I didn't bother fitting the switch, on-off switch, because if you want it off, you just disconnect, because you don't use it 24 hours. And I use a rechargeable battery, and the rechargeable battery lasts me for a long time, maybe 3 weeks, maybe a month, type of thing. Or you can use a Duracell batteries. But as I said, I prefer rechargeable battery because it's got a double-sided tape. I can remove it and so on. Yeah, on that note, basically, I hope, you are with me what I'm trying to portray and what I'm trying to sort of explain this induction tester, inductor tester, should I say, which works on electromagnetic induction principle. Yeah, of course, they're very reliable. They don't give the problem as long as you don't smash it or you don't, but you can, it's very tough. You can hit it, you can, because it's totally sealed, waterproof and so on. So yeah, on that note, I say thank you for watching Bato's electromagnetic induction principle inductor tester. Thank you.